Okay, so from all the slide is going to look like a PDF file. So let me see if I can make it. Okay, so I'm going to make it look like a big screen. Uh, so the presentation is full screen. Okay, so let us do one example now. So you're given these 5 matrices A1 up to A5, and these are the dimensions. So again we'll follow our convention. So the matrix index is 1, so its dimension is P0 by P1. Matrix A2 is P1 by P2, A3 P2 by P3, and so on. So these are the numbers for this example. A1 is 3 by 4. So A2, you see the number of columns in A1 should match with the number of rows in A2. So it is going to be 4 by 5. Then this is going to be 5 by 2. Then this is 2 by 7. This is 7 by 2. Okay. So for an assignment, I think I had already posted, I would have given just P0, P1, P2, P3, P4, P5. So based on the convention I explained here, you should be able to pick out the dimensions. So when I give you just like this, P0, P1, P2, P3, P4, P5, it means we have 5 matrices. A1 of dimension P0 times P1, A2 of dimension P1 by P2, A3 of dimension P2 by P3. Okay, so follow the convention explained. The index for a matrix is say A1, its row is 1 less than that, P0, and then P1, the same index as the matrix index, A2, P1 by P2, and so on. Okay, so I would have assigned numbers like this for each one, and we should be able to pick up the dimensions from there. Right, so let us now start this example. So we're going to maintain 2 tables. I'll call the M table, which is going to store the minimum number of multiplications we need to do to multiply a subchain. So the row entries are the I, and the column entries are the J. So here we have 1 through 5, so it's going to be I equals 1, 2, 3, 4, 5, and the column is J equals 1, 2, 3, 4, 5. Okay. Okay, so alright, then the K table is going to store the K value where we parenthesize. So again we have same I equals 1 through 5 and J equals 1 through 5. Alright, so to begin with, I equals J. So when I equals J, as you saw in the recursion, we don't need to do any multiplication when I equals J. So the number of multiplications we need to do for I equals J, this diagonal cases, is 0, and we don't need to choose a K because I is same as J, just one matrix, so this is kind of null. Okay, so the actual calculations start when I is less than J, so that means where we have to fill this diagonal. So as you see, we don't need to fill the lower diagonal of this matrix, we don't need to fill these entries because these entries correspond to I greater than J, and that doesn't make sense. You have a chain AI to AJ where AI, the index I, is greater than index J. That's not reasonable. So we'll fill only the top upper diagonal of this matrix where I is like less than J. Okay, similarly for the K table, we'll fill only the top cells, the upper matrix. Okay, so now we are going to work with what is called a spread, means I is less than J, right? So J minus I should be some positive value. So if I is less than J, J minus I will be some positive value. So we'll start with 1, right? That means the difference between the index I and J is 1. So that means you're going to fill up these cells. I is 1, J is 2, that's the difference, spread of 1. I is 2, J is 3, that's a spread of 1. I is 3, J is 4, that's a spread of 1. I is 4, J is 5, that's also a spread of 1. So you're going to fill up these 4 cells. So the k table we are going to accordingly update. So again we are going to make use of this general recurrence, okay, so which I have listed here. Alright, so what we are going to find is, so let us start with 1 comma 2. So m of 1 comma 2, now what is our recurrence? We have to pick, so m of 1 comma 2 means I is 1, j is 2. So our k could go from I less than equal to k less than j. So I is 1, j is 2. So k can be only what? Only one value, which is I less than equal to k. So k is 1 and it cannot be equal to j, is less than j. So k cannot be 2. So when I is 1, j is 2, k can be only 1. So if k is 1, what is this recurrence? So the recurrence, this is a general format. M of I comma k plus m of k plus 1 comma j plus pi minus 1 times pk times pj. So you see, you basically fix I and j. So you're trying to find m of I comma j, right? So you fix I and j and you're just playing with k. So for this case, we fixed k as 1. So it's going to be m of I comma k, which is 1 comma 1, plus m of k plus 1 comma j, plus pi minus 1 times pk times pj. That's the recurrence, right? So now you see, like any dynamic programming problem, when you want to solve the larger problems, you would have found the solution for the smaller sub problems already. So m of 1 comma 1 is this diagonal, this cell 0. M of 2 comma 2 is this cell 0. So this P0, P1, P2, we know the dimensions. So we can multiply 3 times 4 times 5, which is 60. So that is the number of multiplications to multiply AI to AJ, which is 1, 2. That's simply multiplying A1 and A2. So you want to multiply A1 and A2, that's going to be the dimension. 3 times 5 and 4 by 5. So it's 3 times 4 times 5, that is 60 multiplications. Similarly, if you want to multiply or find the number of multiplications from 2 and between 2 and 3, so from 2 to 3, I is 2, j is 3. So just apply the recurrence. M of, and k is going to be here what? 2, because k can be what? I less than equal to k less than j. So k can be 2 and the next integer is 3 and k has to be less than j. So k cannot be 3. So k is only 2. So the recurrence is m of I comma k plus m of k plus 1 comma j plus pi minus 1 times pk times pj. So this is I comma k, so 2 comma 2 plus k plus 1 3 comma 3 and p1 p2 p3. So substitute those numbers, you get 40. So that is 40. Now as you do this, you record the k table also. So we got this 60 for k equals 1. That's the only value of k we consider for the cell 1 comma 2. So record that entry as 1. That's the value of k we consider. Similarly here, to get this 40, we considered k as 2. So record that k value here. Now similarly, if you want to multiply and find m of 3 comma 4, that is like what? Again, the only possible k is value of k is 3, because k I less than equal to k less than j. So m of I comma k plus m of k plus 1 comma j and pi minus 1 pk pj. So 5 times 2 times 7 is 70. So to get this 70, you used k as 3. So record that. Okay. So again notice m of 3 comma 3, m of 4 comma 4 are both zeros, because this is like same as I equals j case. So those come from the diagonal cases. So you see, when the spread is 1, which means the difference between I and j is 1, you have only one possible value of k, and this is the case. So now let us look at, let me make it this way so that's easy to follow. Let me see. Okay, we'll do like this. me try one option. I'll share my screen. Let us see if I can use a PDF file and make it big. Okay, so hope everyone can see my screen and how it looks like. I think it shows up there, right? Okay, so alright, so I think this is bigger now to look at my PDF file. So it's easy to explain with this. Alright, so let us now look at the spread of 2. So spread of 2 means the difference between I and j is 2. So that means you're going to fill these 3 cells. I is 1, j is 3. This cell I is 2, j is 4. This cell I is 3, j is 5. So we're going to fill up these 3 cells. So let's do one at a time. So m of 1 comma 3. So that's what we want to compute. So I is 1, j is 3. Right? So that means what are the possible k values? So again, the recurrence is here. So I less than equal to k less than j. So k could be 1, which is equal to I. Then k could be 2, that is okay 2. But k cannot be 3 because k is like equal to I but less than j, right? So anything between starting from I to less than j. So I is 1, j is 3 means k could be 1 and k could be 2. So if k is 1, what is the recurrence? M of I comma k. So I is 1 again. So 1 comma 1 plus m of k plus 1 comma j. So k is now what? 1. So 1 k plus 1 is 2. So m of 2 comma j is 3. And I is 1. So you fix I and j as 1 and 3. So I minus 1 is p1 minus 1. So p0 times k is 1. p1 times p3. So that is this dimension. So m of 1 comma 1 is 0 because it's the same matrix. Then m of 2 comma 3 we found in the earlier iteration, which is m of 2 comma 3 is this 40. And p0 times p1 times p3 is going to be this 3 times 4 times 2. So that's going to be totally 40 plus this 12 times 2 is 24. So that's going to be 64. So if k is 1, the number of multiplications we have to do is 64. So repeat the process for k equals 2. So if k is 2, what is the sum? So m of I comma 2, I is 1, so 1 comma 2 plus 2 comma j is 3 plus apply the values. So I is 1, so I minus 1. So you see, once you fix I and j, p0 is I minus 1. So p0, p3 get fixed. all you have to do is insert the k dimension. So k is 1, so it's p1, k is 2, so it's p2. So p0 times p3 times is p2. So m of 1 comma 2 we found in the earlier iteration as 60, m of 3 comma 3 is 0, plus these three, p0 times p2 times p3 is 3 times 5 times 2, so that's going to be 90. So the minimum of 64 and 90 is 64, and that came from k equals 1. So we record 64 here for m of I equals 1, j equals 3, and record the corresponding k value here, I equals 1, j equals 3. That cell we record the k is 1 because we got the 64 by choosing k equals 1. So let us do now m of 2 comma 4, which means I is 2, j is 4. So our k is either 2 or 3. So if k is 2, what is the recurrence looks like? So m of, again we fix I and j, so I is 2, 2 comma 2 plus m of 3 comma 4 plus, you see, k, I and j, so this is pi minus 1, so it's going to be p1, and this is pj, so it's going to be p4, so p1 times p4, and k is 2, so that's p2, that is pk. So from here pick your p1, p2, p4, multiply them, and m of 2 comma 2 is 0, 3 comma 4 we just found in the previous iteration as 70, so the result is 210 for k equals 2. Now for k equals 3, it's going to be, you see, again you can do it even from here, so you fix k here as 3, so, and again I and j are fixed as 2 and 4, so this is your I, this is your j, so m of 2 comma, now k is 3 plus k plus 1, so m of 4 comma this 4, and p1 p4 are fixed, but you multiply now in between by p3 because k is 3, so p1 which is pi minus 1 times pk which is p3 times pj which is p4. So again m of 4 comma 4 is 0, but m of 2 comma 3 from the previous iteration is 40, so 40 plus 0 plus this p1 times p3 times p4 is 96. So the minimum of 210 and 96 is 96, which comes from k equals 3. So you record for m of 2 comma 4 as 96, and the corresponding cell k is 3. Now do the same process for I equals 3 and j equals 5. So you have the possible values of k are I, then so on up to something less than j. So 3 and 4 are the possible values of k because this is also spread of 2. So from the recurrence it is m of I comma k plus m of k plus 1 comma j plus pi minus 1 pk pj. So I is 3, j is 5, so 3 comma 3 plus 4 comma 5. Then again I is 3 means this is pi minus 1, so p2, p5 for j, and then pk, this k is 3. So you can get these values from the earlier iteration as well as the dimensions given. So 3 comma 3 you do 0 multiplications, then m of 4 comma 5 is 28 plus this. So for k equals 3 you do 48 multiplications. Now for k is 4, this is m of 3 comma 4 plus m of k plus 1 comma j, so which is 5 comma 5 plus p2 p5 are fixed, it's just k equals 4, so p4. So m of 3 comma 4 is 70, then m of 5 comma 5 is 0 plus this, so you get 245 multiplications for k equals 4. So the minimum is 48, so that comes from k equals 3. So that's what you record in this m and k tables. Okay. So let me stop for a minute and see if you have any questions right here. Let me see if I can pull up this. Any questions? Okay, so if you don't have any question, let me continue. So now we'll do spread of 3. So for spread of 3, what we have to do? So these are the two cells. I is 1, j equals 4. I is 2, j equals 5. So these are the two cells we have to compute. So I equals 1, j is 4. So k ranges from I to something less than j. So k could be either 1, 2 or 3. Now accordingly we have to come up with the recurrence. So if k is 1, m of 1 comma 1, and k is 1, so k plus 1 is 2. So m of 2 comma j is 4, and pi minus 1. So this is I is 1, so p0 times pk times pj, which is p4. So m of 2 comma 4 we just found from the earlier iteration as m of 2 comma 4 is 96. M of 1 comma 1 is 0. So 0 plus 96 plus p0 times p1 times p4 is 3 times 4 times 7. So the result is 180 for k is 1. We do the same thing for k is 2. It is m of I comma k. So I is 1, so 1 comma 2. M of k plus 1 comma j. So it's m of 3 comma 4. Then p0 times p4 times is in between p2 because k is 2. So m of 1 comma 2 we got as 60. Then m of 3 comma 4 we got as 70. And this is p0 times p2 times p4, which is 3 times 5 times 7. So plug in the numbers and do the math. So it's 235 multiplications for k equals 2. Now for k equals 3, it's the same way, m of I comma k, so 1 comma 3 plus m of k plus 1 comma j, which is 4 comma 4, plus pi minus 1 pj times pk in between. So m of 1 comma 3 we got as 64. M of 4 comma 4 is 0. Then p0 times p3 times p4 from this is going to be 3 times 2 times 7, which is like 106. So 106 is the minimum between among 180, 235 and 106. So 106 is the minimum number of multiplications for m of 1 comma 4, and we got that from k equals 3. Okay, so we record that 106 and the k table 3. Similarly, we can now do m of 2 comma 5. So k values are going to be 2, 3 and 4. So for each value of k, now we have to find the number of multiplications. So for k equals 2, it is m of I comma k plus m of k plus 1 comma j plus pi minus 1 times pj, and k equals 2, so it's p2. So plug in the take the values from the table for the smaller sub problems. M of 2 comma 2 is 0, m of 3 comma 5 is 48. Then p1, p2, p5 is 4 times 5 times 2. So for k equals 2, we require 88 multiplications. Then for k equals 3, just substitute the recursion again. M of I comma k plus m of k plus 1 comma j, pi minus 1, pj and pk. So you get 84 multiplications for k equals 3. I think by now we should have figured out how you take the values from the table for the smaller sub problems and substitute dimensions here. So for k equals 4, again you will do m of I comma k, m of k plus 1 comma j, and pi minus 1, pj and pk. So for k equals 4, I got let's see, this should be 4, that's a typo. So k is 4, I get 152. So the minimum is 84, which I get from k equals 3. So you record m of 2 comma 5 as 84, and the corresponding k value is 3. So the last iteration is for a spread of 4. That means we need to compute I equals 1, j equals 5. So that means the k values can be 1, 2, 3 and 4. So for each of these k values we need to find the number of multiplications. So m of I comma k is m of 1 comma 1 plus m of k plus 1 comma j. So it's 2 plus 2 comma 5 because k is 1, k plus 1 is 2. Then you see p0 because of pi minus 1 because I is 1. Then pj, so it's p5, and then pk is k equals 1. So you see, for different values of k, the only thing that changes here is the pk. So you can think this as more, this is a general format. So even in the earlier iterations, we did the same thing for the different k values. So is m of I comma k, m of k plus 1 comma j. So that means for next k equals 2 is like m of 1 comma 2 because this k is 2, then 3 comma 5. Then in between you have p2, then 1 comma 3 and 4 comma 5, and you have p3, then 1 comma 4 and 5 comma 5. Okay, so just increment one index here for the column and then one index here for the row and appropriately adjust the values. Okay. So you plug in the values for smaller subproblems from the table and compute the numbers. So I get 108 for k equals 1, then 138 for k equals 2 and so on. So the minimum is 104 for k equals 3. So this 104 is recorded here and k equals 3 is recorded here. So now we have filled the table and we have found the answer that to multiply from A1 to A5, which is the cell here is I equals 1, j equals 5, it says we do 104 multiplications. So that's the minimum number of multiplications to multiply A1 times A2 times A3 times A4 times A5 of these dimensions. Now we have to also find out where to parenthesize things. So to multiply from A1 to A5, the answer is we do 104 multiplications. Now how to split this chain to subchains? So it says here the corresponding k table for I equals 1, j equals 5, the k is 3. So that means we split at 3. So A1, A2, A3, A4, A5 we split at k equals 3. So it is A1, A2, A3 is one subchain and AK plus 1 to AJ is the other subchain. So this is AI to AK and the other subchain is AK plus 1 to AJ, that is A4 and A5. So now we are not done yet because we need to know how to split this subchain of length more than 2. If it's just subchain of length 1 or 2, we don't need to split further. But if we have length more than 2, we need to show how to split that further. So A1, A2, A3, how to split it? So the answer is here. A1 to A3, it says what? The split is at k equals 1. So that means we have to split right here. A1 by itself and then A2 and A3 because the split is at 1, that is our k. So we split at A1 and then multiply A2, A3. So this is how you multiply this subchain. You multiply A2, A3 first, and then whatever the result of that multiplication is, multiply A1 with that result. And whatever is the result of this A1, A2, A3, multiply that with the result of A4 times A5 and we get the result of this entire chain. So if you multiply like this, you're going to minimize the number of multiplications. Okay. And as you do this, you can also cross check whether you did the math right. So let us see how to do that. So once we decide how to parenthesize, we can then go from the solution. So we see we need to multiply A2, A3 first. So go with the dimensions I have given you. So A2 and A3 is of dimension what? 4 by 5 and 5 by 2. So to multiply A2, A3 we need 4 times 5 times 2. So that is how many multiplications? 4 times 5 times 2. 40 multiplications. So 40 multiplications to multiply A2 and A3. And what's the dimension of the result matrix? It's going to be a 4 by 2 matrix. A2 and A3 multiply, the result is a 4 by 2 matrix. Then you're going to multiply A1 with the product of A2 and A3. So A1 is what dimension? 3 by 4, and this product is 4 by 2. So 3 by 4 with 4 by 2. So the common dimension is 4. So 3 times 4 times 2, that is 24 multiplications to multiply A1 with this product. And the resulting matrix is going to be a 3 by 2 matrix. Okay, because it's 3 by 4 by times 4 by 2, so it's going to be a 3 by 2. The common dimension goes away, so a 3 by 2 matrix. So that is the dimension of A1, A2 and A3. Now A4, A5. A4 is 2 by 7, A5 is 7 by 2, so it's like 2 times 7 times 2, 28 multiplications. And the product A4, A5 is going to be a 2 by 2 matrix. So now we have A1, A2, A3 is a 3 by 2 matrix. A4, A5 is a 2 by 2 matrix. So we multiply these two subchains to get the overall chain multiplication value. So it's 3 by 2 times 2 by 2. That's going to be what is a 3 by 2 final product matrix. And how many multiplications to multiply these two subchains? 3 times 2 times 2. So that's going to be 12 multiplications. So totally how many multiplications we did? For A2, A3 we did 40 multiplications. To multiply A1 with the product of A2, A3 we did 24 multiplications. Then A4, A5 we did 28 multiplications. Then to multiply A1, A2, A3 with A4, A5 we do 12 multiplications. So add up all these numbers, 40 plus 24 plus 28 plus 12. That should come to 104, which is what you have from A1 to A5. That's the number of multiplications. So when you do this problem, after you get all these tables and you decide how to parenthesize, you can cross check whether you did all the math right. Okay, so I'll stop for a second here to convert the video.